Okay, so number 5. This is what you lovingly refer to as a fraction buster. Um, we did fraction busters in Math 1. I don't think that they touched them in Math 2. It could have been 2 full years since you've done a fraction buster. But it's super important. It comes up a lot in Math 3. It's basically like, how do we make this an easier equation? Okay, step 1. You look at the denominators of the fractions and find the least common denominator. And in this case, the least common denominator is 6. That's because 3 goes into 6 evenly and 2 goes into 6 evenly. Okay, now if you put 18, this problem would still work. Do you see where I got the 18 from? 3 times 3 times 2? Yeah. So it would still work. I like to find the least common denominator because I'm a lazy human being and I want my numbers to be small. Okay. Now, step 2. Multiply all of the numerators by the least common denominator, making sure that you see that -6, that -6, pretending that's over 1, and that's also a numerator. Okay, so this would be 1 times 6 is 6 over 3n minus 6 times 6 is 36 equals negative 11 times 6 is 66 over 2 plus 2 times 6 is 12 over 3n. Okay, and then this is the moment of truth. If you did it correctly, you should be able to divide and get whole numbers for everything. So 6 divided by 3 is 2. 66 divided by 2 is 33. 12 divided by 3 is 4. Voila, we now have all whole numbers. Yay. Okay, now for me, when I have letters on both sides of an equation, I start with the lowest one that has a letter on it and undo that first. So you don't have to do it that way. It's just my thing. Okay. I already know. Mrs. Talbot, you have a question? Yes, Mrs. Talbot. Is it okay if I leave my answer as -1.5? Well, kind of. You guys ever hear the phrase, what happens in Vegas stays in Vegas? Okay. What happens in fractions should end in fractions. What I mean by that is the problem starts in fractions, it should end in a fraction. The problem starts in decimals, it should end in a decimal. Am I being picky? Yes. But mathematical etiquette says that answer should be a reduced fraction. Okay. Next, number 7. We're actually going to do 4 warm-ups today. We're going to do 2 of these and 2 of the domain and range ones. So buckle in for the amount of warm-ups we're doing. This is the maybe third most important skill to be successful in Math 3, simplifying square roots. If you had Mr. Guinan, this is called breaking twins out of jail. Okay, what I like to do is make a factor tree. So what multiplies to be 252? 2 and something. 126? Yeah. Okay, 126 is 2 and 63. 63 is 9 times 7. 9 is 3 times 3. Okay, now we're simplifying square roots. That means we're looking for pairs. Do you see any pairs of prime factors? Twos. Circle, cancel. You can make it two sixes if you want to. Do you see a pair of threes? Circle, cancel. The circled ones come outside the square root and get multiplied. And anything left over stays inside the square root. 6 root 7. Okay, we're going to do lots more of those if you need more practice on that, which you probably do, but there's just your first reminder of the year. Okay, now flip the page over to the domain and range warm-ups. Yes. Okay. By the way, just to warn you, I have all these goofy sayings, like the Vegas thing. I say stuff like this all the time. I like to make it as fun as humanly possible because it is math. If I can do anything to make it fun, I will, even if it's embarrassing for me. This concept, domain and range, I like to call it a crock-pot concept. Have I said crock-pot concept to any of you in the past before? Okay, what I mean by that is some concepts that we learn in math, we can learn immediately, that same day, totally got it, walked out, understood. Domain and range is a slow simmer. Like, you have to do them over and over and over again to totally get it. I want you to know that my youngest kid in calculus still struggles with domain and range. It's okay. If you don't get it today, it's okay. You might get it 5 days from now. You might get it next week. You might get it 3 Thursdays away. If we don't know, it's hard. I totally understand. So some stuff easy, this is not. Okay, however, we do this page in Math 1, so throw that out there. Okay. First thing you need to know is domain is the x's and range is the y's. How do I remember that with one of my dumb things? I say X and Y is in alphabetical order and D and R is in alphabetical order. That's how I remember. Okay. Which X's are on this graph here? Yes. Okay. And what I like to do for this, I'm going to get out an obnoxious flare pen. I'm going to actually mark the axes. So the only x's on this graph are -3 and 2. Those are the only x's that exist. -3 and 2. Okay, contrast with that. What are the possible y's on this graph? Yeah, 2, 7, 19, 36.2, pi, square root of everything. The answer is everything. Okay, so what I'm going to do, yes. You remember. So what I'm going to do is kind of trace it along the y-axis because this arrow goes up forever. This arrow goes down forever and they connect right there. So it covers everything. And what we do is we call that all real numbers. And I make a fancy R with 2 stems. It has 2 stems because back in the day when we didn't have expo markers, you wrote on a chalkboard and it was supposed to be bold. So the way they bolded it was make 2 stems. Okay, next question. Is it a function or not? You're searching your brain. I see it. You're trying really hard. Anybody remember what that means? It starts with a V and rhymes with vertical line test.
Vertical line.
Yeah, vertical line test. Okay, so the vertical line test tells you that if it's a function or not, if it's a graph, and what you're supposed to do is draw vertical lines. And if it hits any spot in the graph twice, it fails. So this would be a failure of the vertical line test because I drew a vertical line right on this arrow and it hit it infinite times. It would definitely hit it twice. So this is not a function.
Oh, I remember now.
That's the part that's going to come back to you the fastest. The domain and range part's going to need a minute, and it's okay. Okay. Let's practice this again. I know. It's okay. It's okay. Okay, what are the possible x's we have in this picture? A lot.
-5 to 5.
-5 to 5. Now here's my question, Violet. Are we including -5? No, because it's open. I need to make that look more open. Okay, so notice it looks like Baymax with one big I and one small I. So the way that I write that is -5 to 5. X in the middle because we're talking about domain. And then this side is open and this side is closed. You still have it. Yeah. Okay. You did do this last year?
A little bit,
Okay.
but it wasn't with like the whole graph, right? Yeah.
Every single math teacher does something different. So I don't know. I just work here. Okay. Now, what are the possible y's we have on this one? Uh-huh. Yes. And are they both included? Yes. Okay. So notice this one's open, but don't let that fool you because it's closed here and here. So that means it's closed. Do you want me to say that again? Okay. This is open, but don't be fooled by that because it's closed here and it's closed here. And once it's closed, it's closed. Okay. So range goes least to greatest. A y in the middle because we're talking about range. Close, closed. Okay, and then vertical line test. La di da 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 di. I did not hit it twice ever, so it is a function. Don't we do that slower?
I think you hit it a lot of times.
No. Each line only hit it once.
Oh, okay. So, okay.
It has to be that same line hits it twice. Okay, let me show you a visual. Yes, a function, not a function. Because I would draw one line and hit it twice.
Oh, okay.
Yeah. Okay. Let me make sure that everybody got that before I get all excited. Okay. Now, can you all flip to what you were supposed to work on last night, whether or not you did? No judgment. The math 1 and 2 review or 2.
Oh, this guy? That was the back there.
Okay. Guys, were there any burning questions on this that would prohibit you from moving forward? Take a look at it. This is not due today, it's due tomorrow. I just wanted to see if I could help in any way at the moment. For what? Number 14? Okay. So we kind of went over this today a little bit. It's okay. Okay. So I'm going to do the factor tree. What times what is 45? Nice, nice. This is actually really good. I'm glad you brought it up because I felt like we needed to do one more and we didn't. Okay, now 9 is 3 and 3, and I got it down to the primes now, meaning 3, 3, and 5. I'm looking for pairs. See a pair of 3, beautiful. Okay. Circle cancel. Okay, and this is your question. I hear it already. You want to take that -6 and multiply it by the circled one, and then the leftover guy stays inside. -18√5. Excellent question. Super important. Because in a couple of days, we're going to do quad formula stuff, and that's in there. Yes, 7, yeah. 7. I'm stuck on the warm-up page now. Oh, yes. I'm so glad. Did you meet me before class and be like, Mrs. Sabat, what could I ask today to make your life easier? And I would be like, could you ask for number 7? And then you ask for number 7, and then it helps everybody. Okay, we did not talk about this yesterday, but it was on the digital escape. This is actually going to help you with your digital escape also. This is called a difference of squares. Okay, difference of squares. I'm going to channel my inner Guinan. How can you tell that it's difference of squares? Difference of 2 squares. It's the difference of 2 perfect squares. Okay, so difference means subtract. And then 2 things that have something that multiplies by themselves. Okay, so when I do these problems, I like to go like this. X, 5y, 5y. Just pause there, make sure that makes sense to you. We got that so far. Okay. Then x plus 5y, x minus 5y. And it has to be 1 plus and 1 minus because it's subtraction, and a positive times a negative is a negative. We did not touch on that yesterday. That's another type of factoring, but it was definitely in the digital escape. Now, if you ever get stuck, this is Diamond-in-a-Boxable if you put plus 0xy in the middle. But I wouldn't do that because it's too much work and I'm lazy. Excellent question. Okay, now is the first time we're going to use our notebooks. So if you did not bring a notebook yet, or you don't have paper, I have extra graph paper over here. You guys could come grab that, please. Okay, so when you guys see something like this up on the screen, you're going to set up your notebook. I have the whole chapter done in my notebook already because I'm extra, but I did it over the summer while I was watching some television show. Great. Anyway, so when you see something like this, that's your setup, so you're gonna go ahead and write that down. It's like equivalent to writing the problem down. I try to leave the same amount of space I leave because I'm going to put other stuff. Okay, and then just rest for a second when your notebook's situated. Because this is gonna be almost the last bit of me talking in front of class, so. Okay. Can you guys find the 4 laminated function machines that I put on your table? Okay. You have 2 puzzles to figure out using the same function machines. You need to figure out the order that they need to go in. So the order of the colors, or the order of the names, like F, then G, then H, or K, or whatever. For you to get an initial input of 6 and a final output of 11. Okay, do those words make sense? Okay, so you're gonna take a 6. I would have people with a calculator to like guess and check. And you're gonna use reasoning to try to figure out which one would make sense to go first, like square root of X. Do you think you're gonna square root 6? Like, do you think, no, that's probably not gonna be your first one, because that would come out to a horrible decimal. So just try to reason out, okay, so we've pretty much figured out square root of X is gonna go first. Do you see what I'm saying? Okay, you're gonna try to put them in order. Whatever output you get from one machine becomes the input into the next machine, so it drops into the next machine, drops into the next machine. You want to get an 11 at the very end. Does that make sense? Okay. So let me show you a visual. Don't be offended. I see a lot of your, you see a lot of your faces. So we did this in Math 1 today. And so what I mean is they had an initial input, they put it in a function machine, got an output, dropped that number into the next one, dropped that number to the next one, final output. Do you see what I mean?
Yeah.
You got to find the order. Okay. So you're going to write the order here. Okay, now, wait, before you go, before you start. Okay, before you start, because I want to just let you work. When you guys get this figured out, call me over, I'll check your answer. Then work on your digital escape. Do you guys know what the homework is? And then, do you guys know there's a quiz on Friday?
Yes.
Did you get my email about it?
Yes.
Okay, did you see that there was a Google Classroom post about it? 3 topics, what were they? Factoring, nice, nice. Graphing a line and finding the X and Y intercepts. Okay, and then just solving a regular equation. And it's not a fraction buster, it's just a regular equation, like with distributive property and whatnot, whole numbers. However, there was one piece of information in there that was really important. Did you notice it said no notes, no calculator?
Yeah.
Yeah. Okay. No calculator. I want to see what you have in the debate.
It's okay.
We do not mark you off badly if you mess up a multiplication table, I promise. Everybody does it. It's okay. I just want to see. Okay. And everything up to 12 times 12 is fair game. So if you need to get an app on your phone that reviews your multiplication tables for the next couple of days, and where you get to like pop a goldfish tank or something, that would be great. Okay, so I'm gonna walk around and help, but puzzles, things, then digital escape. Hopefully you'll finish by then. Okay.
Oh, I see.
The instructions are easy.